Okay, so today we are going to discuss about the six-member heterocyclic compound. Six-member heterocyclic compound. So there is one ring in front of you. Try to give the name as per IUPAC nomenclature system. I am waiting in chat box. Try to give the name as per IUPAC nomenclature system. Is anyone? Nishant, pyridine is not IUPAC nomenclature system. I am asking about IUPAC. I am not asking about the common name. Correct. Kiran Badguzar, Azain is correct. Pyridine is a common name and IUPAC name is Azain. See here, Aza is a Aza is what? The prefix, and INE is the suffix. So you have to replace this A with INE, then it will becomes Azain. So Azain is a IUPAC name of this compound, but most of you have already given the correct answers. This ring commonly known as pyridine. So as we have discussed in last lecture that most of the heterocyclic rings are popularly known by their common names instead of their IUPAC name. So always remember the pyridine is a six-member heterocyclic ring containing only one nitrogen. म्हणजे 6 मेंबर रिंग की ज्याच्यामध्ये नायट्रोजन प्रेझेंट आहे अशी रिंग म्हणजे पिरिडिन रिंग. म्हणजे आपल्याला बोलण्यातून आपण हे लक्षात ठेवू शकतो. पिरिडिन रिंग म्हणजे काय? 6 मेंबर हेटेरोसायक्लिक रिंग containing one nitrogen and all bonds, all double bonds, that is fully saturated. That is pyridine. And if you remove the saturation or remove the unsaturations, it will become saturated compound. So this is the saturated compound. Now name of this ring get changed. And now you have to remember now, because here we cannot able to give the name as per IUPAC, we can able to give the name, but try to remember its common name. Because in exam they asked draw the heterocyclic ring from common name, not for IUPAC name. लक्षात घ्या विद्यार्थी मित्रांनो, आता आपल्याला कॉमन नेम वरून हेटेरोसायक्लिक रिंग लक्षात ठेवायचे आहेत. आयुपॅक नेमचे रूल्स आपल्याला एकदा लक्षात आले की मग आपण कॉमन नेम आपल्याला समजले पाहिजेत की कुठल्या रिंगला काय म्हणतात. पिरिडिन म्हटलं की पिरिडिन म्हणजे काय की 6 मेंबर हेटेरोसायक्लिक रिंग कंटेनिंग नायट्रोजन फुल्ली अनसॅच्युरेटेड. आता ह्या अनसॅच्युरेशनचं सॅच्युरेटेड सिस्टीम झाली म्हणजे या ठिकाणी पहा कुठेही डबल बॉन्ड तुम्हाला दिसणार नाही ह्या रिंग मध्ये. आणि या रिंगचं नाव मग आहे पायप्रिडिन. काय म्हणतात या रिंगला? पायप्रिडिन. सो पायप्रिडिन इज अ सॅच्युरेटेड फॉर्म ऑफ pyrimidine. Pyridine, saturated form of pyridine. So pyridine is unsaturated and piperidine is a saturated. Saturated means what? Carbon carbon, or it is single bond, and unsaturated means what? It is containing multiple bonds or double bonds. Okay, so pyridine is a 6-member nitrogen containing heterocyclic ring which is unsaturated, and piperidine is a nitrogen containing 6-member heterocyclic ring which is saturated. So pyridine and piperidine. Are you getting? Okay. So now if suppose we have added one more nitrogen. So in previous example, you have seen nitrogen is present at one position, but now we have added one more nitrogen at number 2. That time the name of this ring is pyridazine, or someone pronounce me it as pyridazine. Pronunciation कुणी कसं करू शकतं? कुणी pyridine म्हणेल, कुणी pyridine म्हणेल, कुणी pyridazine म्हणेल, कुणी pyridazine म्हणेल. But what is difference between the pyridine and pyridazine? Pyridine is 6-member heterocyclic ring containing only one nitrogen, that is pyridine. And now pyridazine. Pyridazine means what? It is containing 2 nitrogen and second nitrogen is present at second position. So if this nitrogen is absent, then this ring is pyridine. If this nitrogen is absent, then this ring is pyridine. This nitrogen is attached or added at second position. The name of this ring is pyridazine. Name of this ring is pyridazine. So if you want to remember the structure of pyridazine, then you must know the statement of this ring. What is the statement? 6-member ring containing 2 nitrogen, one at first and second at second position. ज्या वेळेस 2 नायट्रोजन एक नंबरच्या पोझिशनला, दुसरा दुसऱ्या नंबरच्या पोझिशनला प्रेझेंट असेल, त्यावेळेस त्या रिंगला आपण म्हणतो pyridazine. So 6-member heterocyclic ring containing 2 nitrogen at first and second positions are called as pyridazine. Are called as pyridazine. Are you getting? म्हणजे आता आपण सुरुवातीची रिंग बघितली होती pyridine. Pyridine containing only one nitrogen atom. So as it containing only one nitrogen atom, so our numbering starts from the heterocyclic compounds or heteroatoms. So we are numbering it either clockwise or anti-clockwise because it does not contain any substituents. Okay. And now the second nitrogen is present at 2 number position. That time that ring is called as pyridazine. So you must know the statement of pyridazine so that you will be able to remember the difference between pyridine and pyridazine. So pyridazine is what? 6-member heterocyclic ring containing 2 nitrogen, one at first position and other at second position. That is called as pyridazine. Now see here, I am going to change the position of second nitrogen in 6-member. So it will shifted from second to third position. See here. So this nitrogen is shifted to third position. So now, if you see in first example, nitrogen is at second position. Now we have shifted the second position of nitrogen at third position. Means 6-member ring containing 2 nitrogen at first and third position. That time that ring is called as pyrimidine or pyrimidine. It is pronounced it as pyrimidine. Pyrimidine or pyrimidine. Now see, this is pyridazine is converted to pyrimidine by changing just position of second nitrogen atom. So statement of pyrimidine is what? 6-member heterocyclic ring containing 2 nitrogen at first and third position. If nitrogen is at first and second position, that time compound is pyridazine. If nitrogen at first and third position, then compound is pyrimidine. Compound is pyrimidine. 2 नायट्रोजन असतील, दोन्ही नायट्रोजन 1 आणि 2 नंबरला असेल तर त्याला म्हणतात पायरिडॅझिन. दोन्ही नायट्रोजन 1 नंबरला आणि दुसरा नायट्रोजन 3 नंबरवर जर प्रेझेंट असेल तर त्याला म्हणतात पिरिमिडीन. ओके, आर यू गेटिंग? समजतंय तुम्हाला? आता हे स्ट्रक्चर ड्रॉ करण्याची प्रॅक्टिस आपल्याला असली पाहिजे. हे स्टेटमेंट आपल्याला लक्षात राहिलं पाहिजे. स्टेटमेंट लक्षात राहिलं म्हणजे आपल्याला फरक समजेल, नाहीतर कन्फ्युजन होईल की पायरिडॅझिन कसं काढायचं आणि पिरिमिडीन कसं काढायचं. हे कन्फ्युजन नकोय आपल्याला. हे कन्फ्युजन आपल्याला नकोय. म्हणून आपण काय लक्षात ठेवलं पाहिजे? याच्यामधला फरक लक्षात ठेवला पाहिजे. ओके, so now we are going to change the position of third number nitrogen atom from third positions to fourth position. See here, this nitrogen, second nitrogen position get changed from 3 to 4th number position. So we have shifted first from second to third, now third to fourth. So 2 nitrogen atom present at 1 and 4th position. That time that ring is called as pyrazine. That time that ring is called as pyrazine. So nitrogen at first and fourth position, that time it is called as pyrazine. Nitrogen at first and third position, then it is called as pyrimidine. Nitrogen at first and second position, it is called as pyridazine. Okay. It is not pyrazine, Pragati. Pyrazine. Okay, correct. So now all the 3 rings, it is in front of you, containing 2 nitrogen atoms. One at 1 and second position, so it is called as pyridazine. 2 nitrogen atoms at first and third position, it is called as pyrimidine. 2 nitrogen at first and fourth position, then it is called as pyrazine. Then it is called as pyrazine. So pyridazine, pyrimidine and pyrazine. Pyridazine, pyrimidine and pyrazine. So you must remember the difference between these 3 structures, because most of the time students think that there is a confusion between these 3 structures. So it's very easy to remember. It is very easy to remember that if the 2 nitrogen is present at first and second position, then it is called as pyridazine. If 2 nitrogen is present at first and third position, then it is pyrimidine. If first and fourth position, then it is pyrazine. So simple. 1 आणि 2 नंबरवर असेल तर पिरिडॅझिन म्हणतात, 1 आणि 3 नंबरवर असेल तर पिरिमिडीन म्हणतात, 1 आणि 4 नंबरवर असेल तर पायरेझिन म्हणतात. म्हणजे पिरिडॅझिन मधला 2 नंबरचा नायट्रोजन जर 3 नंबरला शिफ्ट केला तर ती रिंग पिरिमिडीन होते. पिरिमिडीन मधला 3 नंबरचा नायट्रोजन जर 4 नंबरवर शिफ्ट केला तर ती रिंग पायरेझिन होते. म्हणजे अशा पद्धतीने आपण मित्रांबरोबर, मैत्रिणीबरोबर डिस्कशन करताना सुद्धा आपण हे स्ट्रक्चर लक्षात ठेवू शकतो. ओके, यू हॅव टू जस्ट व्हिज्युअलाइज द डिफरन्स बिटवीन दीज 3 स्ट्रक्चर्स. आपल्याला फक्त ऑब्झर्व करून, व्हिज्युअलाइज करून कारण केमिस्ट्रीमध्ये जर ऑब्झर्वेशन चांगलं असेल तुमचं, तर स्ट्रक्चर लक्षात राहण्याची जी काही क्रिया आहे तुमच्या ब्रेनमध्ये ती चांगल्या प्रकारे होते. त्याच्यासाठी तुम्हाला काय गरजेचं आहे? ऑब्झर्वेशन. जस्ट ट्राय टू ऑब्झर्व द स्ट्रक्चर अँड ट्राय टू पॉइंट आउट द डिफरन्स बिटवीन द टू स्ट्रक्चर and what are the changes is responsible to convert the one name to another name. If you are able to visualize the structures and if you are able to point out the difference between two structure, definitely it will be help to you to remember the chemical structures. लक्षात घ्या मी काय सांगतो. जर तुम्हाला स्ट्रक्चर ऑब्झर्व करण्याची सवय चांगली असेल आणि स्ट्रक्चर ऑब्झर्व करताना जर तुम्हाला त्या दोघांमधला डिफरन्स जर समजला चांगल्या प्रकारे आणि तुम्ही तो पुटपुटून म्हणा, नोटबुक मध्ये लिहून म्हणा, जर तो डिफरन्स पॉइंट आउट केला चांगल्या प्रकारे, तर निश्चितचपणे ते स्ट्रक्चर तुम्ही कधीही विसरणार नाही. एक छोटीशी रिव्हिजन, शॉर्ट टाइम रिव्हिजन जरी तुम्ही त्याला देऊ शकला, तर ते स्ट्रक्चर लगेचच्या लगेच परत तुमच्या ब्रेनमध्ये जसंच्या तसं दिसेल ते आणि तसंच्या तसं स्ट्रक्चर तुम्ही पेपरमध्ये, नोटबुकमध्ये काढू शकाल. So for that purpose, what you required a good observation power. Along with, you should be able to point out the difference between these two structures. So for that purpose only, I have keep all the three structures in one slide so that you can able to visualize the difference. So 2 nitrogen at 1 and 2 position, it is pyridazine. 2 nitrogen at first and third position, it is pyrimidine. 2 nitrogen at first and fourth position, it is pyrazine. So I think this is sufficient for this slide. Okay. Now we have seen the pyrazine, that is nitrogen at first and fourth position. It is unsaturated compound. If we convert it into saturated system, then compound looks like this. Okay, we have done saturation, means we have removed the double bonds. So for that purpose, we have added 2 hydrogen in order to satisfy the all bonds of nitrogen. सुरुवातीलाच मी सांगितलं, बऱ्याच वेळेस आपण हा हायड्रोजन लिहिण्याचं टाळतो आणि मग आपलं स्ट्रक्चर चुकतं. म्हणून हे हायड्रोजन आपण लिहिण्याचे टाळले पाहिजे नाहीत. म्हणजे आपण विसरलो गेलो नाही पाहिजे, आपण हायड्रोजन लिहिलेच पाहिजे. काय केलं आपण? पायरॅझिनचं फक्त हा जो पायरॅझिन आहे याचे फक्त आपण डबल बॉन्ड काढून टाकले. हे जे 3 डबल बॉन्ड आहेत, हे 3 डबल बॉन्ड आपण या ठिकाणचे रिमूव्ह केले. म्हणजे दिस इज अनसॅच्युरेटेड सिस्टीम, दिस इज सॅच्युरेटेड सिस्टीम. So name of this compound is piperazine. Name of this compound is piperazine. आपल्याला एका ड्रगचंच नाव पायप्रेझिन आहे. आपण एन्थेल्मेंटिक मध्ये शिकणार आहोत. त्या ड्रगचं स्ट्रक्चर आहे आपल्याला अभ्यासाला. ही रिंग काढली म्हणजे ड्रगचं स्ट्रक्चर संपलं. लक्षात घ्या, ही रिंग काढली म्हणजे या ड्रगचं स्ट्रक्चर संपलं. You cannot able to give the IUPAC nomenclature, Pooja Badgujar. Always think for now common name, because most of the rules are not applicable for the 6-member heterocyclic ring. So it is piperazine. So what we have seen? We have seen pyrazine, if it is become saturated, means you have removed all the double bonds and added the hydrogens. So name becomes piperazines. So simple to remember how, if you observe the name very carefully, you will find out that the razine portion is remain as it is in the name. And just you have to replace the PY by this PIP. Okay, I will show you how it looks like that. Previously we have seen the example of pyrimidine, that is 6-member heterocyclic ring containing only one nitrogen atom, and if we remove all the double bonds, so that time we have called it as piperidine. आपण हे सुरुवातीलाच बघितलं लेक्चरच्या स्टार्टिंगलाच. Pyrimidine म्हणजे काय? नायट्रोजन containing 6 member heterocyclic ring that is unsaturated, and if we convert this unsaturated to saturated, then name becomes piperidine. And in last slides we have discussed about the two nitrogen, one at 1 and second at 4th position. That time name of this compound is pyrazine, and if we convert it into saturated forms, then the name is piperazine. If you observe the name of these structures very carefully, if you able to point out the, I have already made the difference in color. I have changes the color. See here, PY and here PIPE. Black color is same. Black color text is same for the both structures. Razine. Okay, so blue color part only different. So what you have to replace the PI of your name from pipe if you want to convert it into a saturated form. So whenever the in 6-member ring system, that is pyrimidine and pyrazine, it is converted to saturated, that time you have to replace the PY with pipe. So already your name becomes like that. आलं लक्षात? फक्त काय करायचंय, सुरुवातीचा PY काढायचा आणि पाईपनी तो रिप्लेस करायचा. कुठल्याही पुस्तकामध्ये हा नियम दिलेला नाही, हा नियम नाहीये. हा फक्त आपल्याला समजण्यासाठी आहे, लक्षात ठेवण्यासाठी आहे. दिस इज द वन ऑफ द लॉजिकल ट्रिक्स. It is not IUPAC nomenclature rules. It is not given in any kind of books. So this is just one trick to remember the name of piperidine and piperazine. Are you getting? So you have to, whenever this pyridine is saturated form, so you have to just replace PY from pipe. So it will becomes piperidine. Whenever you want to convert the pyrazine into saturated form, so you have to replace this PY with pipe. Okay, so simple. So PY replace with pipe when there is conversion of unsaturated to saturated. Are you getting? It's so simple logic to remember the name of this compound. So we have seen all the 6-member heterocyclic ring containing nitrogen atoms. We have started with pyridine, isn't it? Then we have added nitrogen atom at 4th position, name is pyrazine. Nitrogen atom at 3rd position, name is pyrimidine. And nitrogen atom is at 2nd position, name is pyridazine. So nitrogen at 1 and 2, pyridazine. Nitrogen at 1 and 3, pyrimidine. Nitrogen at 1 and 4, pyrazine. And nitrogen at 1 and 4 is a pyrazine. And when it is converted to saturated forms, then we have converted their name into piperazine. So you want to just replace the PY by pipe. So pyridine is converted to piperidine and pyrazine is converted to piperazine. For what? For conversion of unsaturated to fully saturated system. So this is all about the 6-member heterocyclic compounds. Okay, now here is one of the ring I have drawn, and then I came to know that the one of the rule in nomenclature of heterocyclic compounds, what to do with the extra hydrogen, isn't it? Now if you see here, you will find out that 2 hydrogen at 4th position, but actually there is only 1 extra hydrogen. दिसताना आपल्याला 2 हायड्रोजन दिसतात त्या ठिकाणी, परंतु तो एकच एक्स्ट्रा हायड्रोजन आहे. एकच का? ज्या वेळेस आपण हे जे अशी बेन्झीन रिंग काढतो ना, किंवा एखादी कुठलीही रिंग काढतो, ज्यावेळेस असे डबल बॉन्ड असतात त्याच्यामध्ये, त्यावेळेस हा जो कॉर्नर आहे ना, हा जो कॉर्नर जो तुम्ही सर्कल केलेला दिसतो, हा कॉर्नर रिप्रेझेंट करतो CH ला. काय रिप्रेझेंट करतो? CH ला. आणि ज्या वेळेस हे जे स्ट्रक्चर आपण चेंज करतो म्हणजे यातला डबल बॉन्ड आपण ज्यावेळेस हा रिमूव्ह करतो, आता पहा हा डबल बॉन्ड रिमूव्ह केला म्हणजे हा जो कॉर्नर झाला, हा कॉर्नर आता रिप्रेझेंट करतो CH2 ला. पहा तुम्ही CH चं रूपांतर कशात झालं, CH2 मध्ये झालं. So this is conversion of CH2, CH2, CH2. How? If you remove this one double bond from here, it means that one hydrogen is added here and one hydrogen is added here. So this CH plus one hydrogen, it will become CH2. So how many hydrogen is added? Only one hydrogen is added at one atom. Okay. Only one hydrogen is added at one atom. So how many extra hydrogen is there in that case? Only one hydrogen is extra for that examples. Are you getting? This is my new rule for you, how to handle with this one extra hydrogen. Are you getting? So whenever double bond is there, that time it is represented as CH. Okay. Once you remove this double bond, so this corner is represented by CH2. So how many hydrogen is now extra? Only one hydrogen is extra for that examples, such a type of examples. Okay. So whenever such a extra hydrogen is there, so how to name such a compounds? So you have to use one prefix. What prefix? You have to number the ring atom that possesses the hydrogen using the italic capital such as 1H, 2H, 3H, like that. 1H, 2H, 3H, like that you have to use. पूजा, प्रत्येक वेळेस तुझं नाव टाकायची गरज नाही. सुरुवातीला समजलं मला तू दुसऱ्याच्या मोबाईल वरून लेक्चर अटेंड करते. एकदा टाकलं बस झालं. ओके, इट इज अंडरस्टँडेबल. ज्यावेळेस एखादा हायड्रोजन ऍटम आपला ऍड होतो त्यावेळेस आपण काय प्रिफिक्स लावायचा आहे? पोझिशन ऑफ दॅट ऍटम, रिंग ऍटम ऑन विच एक्स्ट्रा हायड्रोजन इज प्रेझेंट and capital H. So for that example, the name of this ring is pyran. Common name of this ring is pyran. So what is mean by pyran? Pyran is nothing but the oxygen containing 6-member heterocyclic ring. आता बरेच विद्यार्थी अशी पण स्ट्रक्चर काढण्याची शक्यता नाकारता येत नाही. कसं स्ट्रक्चर पहा, मी तुम्हाला काढून दाखवतोय स्क्रीनवर. बरोबर, 6 मेंबर सांगितलंय, आपण स्ट्रक्चर काढतोय असं, आणि आपल्याला सवय असते बॉन्ड असे काढण्याची. बरोबर, पण आपण हे विसरून जातो की ऑक्सिजनला 2च व्हॅलेन्सी. We have forgot that oxygen has only 2 valencies. So that time this structure is an incorrect structure. That time this structure is incorrect structure. Okay, why? Because oxygen has 3 valency. So for that purpose you need to remember that oxygen has only 2 valency. When we want to draw the 6-member heterocyclic ring containing oxygen, so you must first draw the structure like that. Okay, and then don't add a double bond here. So you have to add double bond here or here, and you can give the numbering from this heteroatom: 1, 2, 3, 4, 5 and 6. Okay, so what happens at 4th position? There is extra hydrogen. So what rule says? You have to handle the extra hydrogen in a such a way that you have to write down the position number and capital H. Capital H indicates the extra hydrogen is present. So in that example, if you see here, we have added the 4H, and pyran is what? Oxygen containing 6-member heterocyclic ring, pyran ring. Okay, so you must remember the name of this ring. Pyran means oxygen containing 6-member heterocyclic ring. Okay, oxygen containing 6-member heterocyclic ring. And why it is 4H? Capital 4H, and you have to write down this H in italic form. Italic form means what? You have to just write down like this. So this is italic. If it is normal, then it is straight one, like that. So this is a normal. So this is incorrect. This is italic. It is correct. Okay. So this is what the one more rule in nomenclature system of heterocyclic compounds. This rule is applicable to imidazole, pyrazole, oxazole, like that. Whenever there is extra hydrogen is there, that time you have to prefix the number of ring atom on which the extra hydrogen is present by using the capital letter of H. So name of this compound is 4H pyran. So remember, when you are going to draw the structure of pyran, that time you have to first draw the skeletal like that. Okay, most of the times you have to draw like that. Okay, most of the students, what they do, like they draw like this hexagon and then write down the O like that. Okay. So this is not correct way to write down the structures. Or most of the times, what you students do, you students may like that, draw like that. You draw first this 6-member ring and then write down the N like that. So that lines are overlapping with the N. So this is the incorrect way to draw the structures. What is the correct way to draw the structures? First, you have to draw like that. Okay. Now we are not in classroom, so we have to familiar with this technology also. So if we were in classroom, that time I will show you how to draw the structure. So first you have to write the heterocyclic compound, hetero compound, and then join the lines. And then properly you have to draw the double bonds like that. Okay, this is the proper way to draw the double bonds. Most of the times students are in a very hurry. What they do? They do like that. Okay, they are written the structures very correctly like that. Okay, and then they can draw the double bonds like that. So where is that double bonds? Where is actual position of double bonds? How the teachers will get that? Okay, so this is not the correct way to draw the structure. This is the correct way. So always remember, when you want to draw the 6-member heterocyclic ring or 5-member heterocyclic ring, you have to follow this method. Okay. So somewhat oxygen is not looks good, but just consider this is an oxygen. And you cannot draw the double bond here because oxygen has only 2 bonds and already the 2 bonds is completed. So we have drawn the double bonds like that. Okay. So this is the correct way to draw the structures. Now, if suppose I am going to shift that double bond from this position to this position, means now this double bond is present between 2 and 3 number carbon atom. Now I will shift the double bond between 3 and 4 number position. How? See here, if double bond is shifted here, so structure looks like this. Structure look like this. See, I have just shifted the double bond between 2 to 3 to 3 to 4. So your structure look like this. Now students made mistakes in numbering now. What numbering mistakes? Monica has asked one questions. Sir, how do give the name the structure that position of what beta? Hydrogen. Can you able to ask the questions again because I am not getting your questions properly. Hydrogen atom. Okay. How to give the name the structure that position? See here already the extra hydrogen is present at 4th number positions, so that's why we have to return the 4th number. How this 4th number come? We will start the numbering from heteroatoms. So numbering should be started from heteroatoms. Okay, and either you can give a clockwise numbering or anti-clockwise numbering. Okay, as it does not contain any substituent, if you numbering from this sides, it also get the 4th number. If you numbering from clockwise, it also get the 4th number. So both direction of numbering is correct. No, don't bother about the other hydrogen atoms. Think only for the extra hydrogens. This rule is applicable for extra hydrogen. This ring is applicable for extra hydrogen because already we are consider this is an unsaturated system. So only think about the extra hydrogen. So there are only extra hydrogen, only one. So 4H means the extra hydrogen present at fourth number position, and 6-member ring containing oxygen is called as pyran. 6-member ring is called as pyran. Okay, now what we have do, what I am trying to say, impart knowledge. I don't know your name, but you have asked one question that, sir, which site is compulsory to give the numbering? That's I am going to explain in that examples. What we have did, we have just shifted the double bonds from 2-number positions to 3-number positions. So what we have get, like this. So now one extra hydrogen is present at this position. Now question is that how to give the numbering. Means either you are following the clockwise directions or counterclockwise directions. So there is one questions in your mind, how to give the numbering either clockwise or anti-clockwise. But we know that one rule, and that rule is says that if the both numbering system is the correct, means what first rule says, you have to start the numbering with the heteroatoms. So already we have started numbering with the heteroatoms. If you follow the counterclockwise, 2, 3, 4, 5, 6, and what number rule says that if there is no other heteroatom, so preference will be given to first heteroatom, that is oxygen. Okay, and now you have to give the preference to saturated compounds or saturated atoms. Saturated atom means what? These are the unsaturated. So this carbon is unsaturated, this carbon is unsaturated, this carbon is unsaturated, this carbon is unsaturated. Why? Because it is involving carbon-carbon double bond. But this carbon is not unsaturated. This is saturated carbon atom. So this atom is what? Saturated. So saturated carbon takes priority in the numbering. So first you have to give the priority to heteroatoms. If it is containing 2 heteroatoms, then you have to give the priority to the second heteroatoms. As it does not contain the second heteroatom, so first priority should be given to the heteroatoms, and then second priority should be given to the saturated carbon atoms. That's why it is given the second position, and on second position extra hydrogen is present. मोनिका लक्षात घे, ह्या एक्झाम्पल मध्ये एक्स्ट्रा हायड्रोजन 4 नंबर पोझिशनला होता, म्हणून आपण 4H पायरान लिहिलं. बरोबर. आता याच्यामध्ये काय झालं, हा एक्स्ट्रा हायड्रोजन तुझ्या 2 नंबर पोझिशनवर आला, कारण 4 नंबरवर आता डबल बॉन्ड गेलेला आहे. बरोबर. म्हणजे हा जो कॉर्नर आहे, आता हा जो कॉर्नर 4 नंबरचा, आता हा फक्त CH ऍक्ट होतो. या एक्झाम्पल मध्ये हा जो कॉर्नर आहे हा CH ऍक्ट होतो. ओके. But once it is shifted, so now this is act as CH2. So one extra hydrogen atom at second position. So name is 2H pyran. Name is 2H pyran. So whenever you found the system like that, okay, that time you have to follow the numbering system in a such a way that the first preference given to the heteroatoms, and then preference given to the saturated atoms. Okay, first preference to heteroatoms and then second preference to the saturated atoms. So these directions of numbering is correct. This site of numbering is correct because it follow all the rules. As it follow all the rules, then at 2 position there is extra hydrogen is present. So 2H pyran means 6-member heterocyclic ring containing oxygen. 6-member heterocyclic ring are called as oxygen. Sir, what are heteroatoms and why it is compulsory to give numbering from the heteroatoms? For that purpose, you need to watch the video of heterocyclic compounds part 1. Okay, in that video I have already taught what are the heteroatoms and why it is compulsory to give the numbering from heteroatoms, because it is the IUPAC systems, that is internationally accepted systems. They have framed the certain rules and we have to follow that rules, and that rules are accepted by internationally. So that purpose we have to always give the preference to the heteroatoms while numbering the heterocyclic compounds. And what is meant by heteroatoms? Heteroatoms are nothing but any atoms which are different from the carbon. So oxygen, nitrogen and sulfurs are the heteroatoms. Okay. So I think you have very well understood the rule, that is handling of extra hydrogens. Okay. So let's see the next example. Now here is two oxygen atom present in a 6-member heterocyclic ring, and name of this compound is 1,4-dioxane. Di means two. Di means two. Oxa means oxygen, and INE for suffix for 6-member heterocyclic ring. Suffix for 6-member heterocyclic ring. So 1, 2, 3, 4, 5 and 6. You can either give the numbering from these directions or these directions, because by adapting the both positions, Nirmala, if there is only CH is present, so there is no need to write 1H or 2H, because CH means the unsaturation. And already you have added the suffix for unsaturated systems. When you are removing the unsaturations or double bonds, that time one extra hydrogen is added. That time only you have to mention the position number of that particular things. Okay, what we have seen here, see here, at 4th number positions there are 2 CH2, and if you consider this 5 number corner, this indicates that it is CH corner. It is always considering CH. just try to think how this CH will comes. जरा लक्षात घेण्याचा प्रयत्न कर, हा CH कसा असेल. इथं तू इमॅजिन कर, एक मिनिट मी तुला this is 5 number position is CH. So this is the one bond with carbon atom, this is another bond, so 2 bond, and with 4th number carbon atom is 3 bonds. So 3 bond is there, carbon is with 3 bonds. So in order to complete its octet, it is always containing H. It is not written, but it is always containing this H. So 1, 2, 3 and 4 bond is completed for this carbon atom. So this corner represent what? CH. In case of this C5, what happens if suppose here, why I have written the extra hydrogen? Because here double bond is not present. So for that carbon atom, if you count the bond, 1 bond, 2 bond, 3 bond and 4 bond. So 4 bond is there. Okay. So whenever we have written like that, okay. So this is the pyridine. So all this corner is represented by CH. So that time there is no need to mention the 1H, 2H, because what? Already it is unsaturated. But once system like that, so here apart from unsaturations, one extra hydrogen is present. Or you can consider this is one of the example. So this is 5-member heterocyclic ring containing nitrogen. So here we have written maximum number of double bonds. So this is pyrrole, but name of pyrrole is always written like that, 1H dash. 1H dash pyrrole. Why this 1H? Because it is fully unsaturated. Fully unsaturated means maximum number of double bond is there. Maximum number of double bond is there. So it is 1H pyrrole. Okay. So all this containing CH, CH, CH. So there is no need to mention the position of CH. But here one extra hydrogen is added. See here in case of second number carbon atom, in that example, second number carbon atom is unsaturated. So it is represented by CH. But in this case, in second example, it is saturated. So it is CH2. So how many hydrogen atom is differed? Here is CH, here is CH2. So one is extra hydrogen. So that's why we have written the extra hydrogen position like that. At second position, one extra hydrogen is there. So dash para. Okay. So name of this compound is 1,4-dioxane. If you replace this oxygen with nitrogen, common name of this compound is morpholine. Common name of this compound is morpholine. Common name of this compound is morpholine. So always remember the morpholine ring means 6-member ring containing oxygen and nitrogen, both at 1 and 4th position. Both at 1 and 4th position. This is common name. Don't try to apply any IUPAC nomenclature rules. It is accepted by universally that it is known by its common name. Okay, so morpholine ring, if in any exam if they ask the questions, draw the structure of morpholine, then you have to draw the 6-member ring containing oxygen and nitrogen. Containing oxygen and nitrogen. So numbering you can give from any direction. Why? Because it does not contain any substituent. So first preference to the oxygen and then prefer to the nitrogen as per preference order. So either you can give clockwise or anti-clockwise directions. Okay, so like that. Okay, so 1,4-dioxane and morpholine is the name of these rings. Now we are going to shift with the 7-member ring. Now try to find out the what prefix and suffix used for 7-member heterocyclic ring. Now I am waiting for your answer. The name of this compound. Prefix plus suffix. Which prefix is used? Which suffix is used? Correct, Rucha, Kiran, Rucha Padguzar. Very good, very good. But you have made one small mistake. As one rule we have just seen that extra hydrogen atoms. One rule that we have just seen about the extra hydrogen atoms. So you have to just add the position of extra hydrogen atoms. So you have to start the numbering like that. Give clockwise or anti-clockwise because it does not containing any substituents or not containing any other heteroatoms. So aza is the prefix used for nitrogen. EP, this EP word is derived from what? Heptane. Heptane. So EP, this EP comes from heptane. Okay. And INE for unsaturated. So epine. So replace this A with epine, so it will becomes azepine. Okay. And 1H. Why 1H? Because at one number position there is extra hydrogen. So name of this compound is 1H azepine. Okay, now I am going to change the position of one of the double bonds, because why? Maximum possible double bond is present here. 7 मेंबर रिंग काढताना हे लक्षात घ्या, आपल्याला कन्फ्युजन 6 मेंबर काढायला सांगितले की नाही, आपण पटकन 6 मेंबर रिंग अशी काढतो. We are able to draw the 6 member ring like that very easily. But now you have to draw what? 7 member ring. So how to draw it? It's very simple. You have to start with this bond. Okay, then do like this. Okay, then do like this, similar way. Now at center you have to return the heteroatoms and just join this. So this is the way to draw the 7 member heterocyclic ring. Okay, now count 1, 2, 3, 4, 5, 6, 7. It's so simple to draw the 7 member heterocyclic. I will show you again. First you have to draw this bond, that is horizontal bond. Okay, then do like this, then straight bond. Once you are done with the straight bond, write down the heteroatoms at center and just join from this center. So simple. 1, 2, 3, 4, 5, 6, 7. So this is the 7 carbon, and this is the maximum possible double bonds, maximum possible. तर आता या ठिकाणी परत तुम्ही डबल बॉन्ड असा काढू शकत नाही. ओके, नाउ आय हॅव शिफ्टेड द पोझिशन ऑफ डबल बॉन्ड. कशी कशी शिफ्ट केली पा पोझिशन? हा बॉन्ड इथे गेला, हा बॉन्ड इथे गेला आणि हा बॉन्ड इथे आला. So name of this compound is, already I have given the numbering, I forgot to remove the numbering, as saturated atoms give the preference. So this is the saturated atoms. So name of this compound is, I am expecting answer from you. Rucha Khindari. Very good, beta. You are so fast. Fantastic. सुदर्शन आत्ताची काल वाटतं लेक्चरला, बरोबर शेवटच्या वेळेस येतो लेक्चरला तू. हा, सुरुवातीपासून नसतो तू बेटा. आणि नंतर म्हणतो मी प्रेझेंट होतो. मध्ये आपला कधीतरी येतो लेक्चरला आणि लगेच गायब होऊन जातो. हा, आणि मग म्हणतो मी प्रेझेंट होतो. चॅट बॉक्सवर तुम्ही किती बोललात, किती जणांनी बघितलं, ते सगळं लिस्ट ऑफ पार्टिसिपंट्स माझ्याकडे डाउनलोड होती बेटा. हा, correct. The name of this compound is 2H azepine. Why 2H? Because now this corner is represented what? CH2. This corner is represented what? CH2. In that example, this corner is represented by CH. कार्बनचे 4 बॉन्डवर आपण हे करायचं. CH, CH2. Now I announce one thing. Every student has to reply with your roll number. Today I am going to take attendance in chat box. If you are attending through different mobile, write down your name and reply in chat box with your roll numbers. Today I am not going to take the attendance from Google Form. So reply in chat box with your roll number. So 2H Ajay Pai. Give your attendance in chat box. If you are attending through different mobile, then directly write down your name and roll number. If you are attending through your mobile, then directly write down your roll number. I will make a copy of this chat box. Very good, fantastic. Very nice. Okay, now we will move further. Why we are starting numbering from this nitrogen atom? Because rule says the numbering started with the heteroatoms and it should be goes like that. The saturated positions takes the second priority. Okay. Now see here, I have made one change. What? The extra nitrogen atom is added fourth number position. Extra nitrogen atom is added fourth number position. So name of this compound is just try to give the name. Richa, Ashfaq, Ananta. Okay, name of this compound is 1H14-diazepine. So di for 1 and 4 position. If you numbering from this direction, then you will get 1, 2, 3, 4, 5. So 1 and 5. And if you numbering from these directions, 1, 2, 3, 4. So 1 and 4 is less. So this numbering is incorrect. Okay. So this numbering is correct. So at 1 and 4, 2 nitrogen, that's why diaza plus keypine. So diazepine. Why 1H? Because it is having extra hydrogen at 1 number position. So the name of this compound is 1H14-diazepine. Okay, 1,4-diazepine. Correct. Remember this structure because you have one drug that is diazepam. In that this ring is present. आपल्याला डायझेफाम नावाचं एक स्ट्रक्चर अभ्यासायचं आहे. ओके, इट इज नॉट डाय 1,4-azepine. कोणीतरी रिप्लाय केलं पहा चॅट बॉक्स मध्ये. So remember this structure because it is very important to remember the structure of diazepam. झोपेची गोळी असते ना, त्या झोपेच्या गोळीच्या स्ट्रक्चर मध्ये ही रिंग आहे 1,4-diazepine. Okay. If you change the position of this, then the number get also changed like that. Okay. So I think we need to stop here. The fuse ring system we will study later. So today we are discussed about 6-member and 7-member ring. So fuse ring system we will discuss in the next lecture. So try to rewatch the today's lectures and try to remember the structures of 6-member and 7-member heterocyclic compound. These are very important ring system because most of the drugs are having this ring system present in their structures. Okay, now the students